Hello everyone and welcome to Thursday's maths lesson. It is the 11th of February and we are continuing with our learning about statistics. So as usual, we're going to warm up by doing our starter. There are two problems here. One of them is linked to the unit we've just finished in area and perimeter. One of them again is linked to one of the previous units in fractions. I would like you to have a go at both. Either on your whiteboard or on your workings paper or on your home learning book, wherever you're getting used to doing it by now, have a go at these two for the starter, and then we'll go through the answers. So pause it and have a go for me. Good stuff. Right, let's get and move on. So the shape is made up of a square and a rectangle. Find the length of side Y. Okay. So we know we've got missing lengths, and we're going to have to use it to find this length y. So what we do is we need to find out this length of the square, and we need to find out this length of a rectangle, and then if we add both those together, we've got y. So for the square, we need to find one side. Now I can't really find this side, or this one, so I don't really know why, but I can find the bottom and top one. And also what we know about a square is going to come in very importantly in a second. So to find this side here, 15 is the whole length here. This chunk is 6. This chunk will be what's left over. So 15 takes 6 is 9. So this side is 9. Now a square, all sides are equal. So that's 9, that's 9, that's 9, that's 9. So this is 9 centimeters. Then we just need this side. And if we look opposite sides of the rectangle are equal. So 4 centimeters means this is 4 centimeters. So 9 add 4 is 13 centimeters. Second one, 5 times 2/3 equals something times a third. Now if this is 2/3, it's double, which means we're halving to get here, which means we have to times it by twice as many. So that's 10. This one, 10 times 3/8 equals something times 5/8. So what I would do is I would do 10 times your 3 to get 30/8, and then we need to work out how to get exactly the same on this side. So how do I get 30 on the top? It's 5 times 6, so it's 6 times 5/8. This one, again, we do just as we did previously. So we need to see that the denominators are not the same on these, so we need to change them to make them the same. So I'm going to change this 1/4 to be eighths. So I times the bottom by 2 to make it 8, which means I times the top by 2. So I've now got 2/8. 2/8 times 5 is 10/8. So then I just need to get 10/8 here. So what do I times 1 by? I times it by 10. So hopefully we got all those. If you didn't, that's all right. It'll still have warmed your brain up. So today we are looking at to identify parts of a circle, because one of the charts we're going to be looking at in the next few days involves circles and knowing about them. So we're going to learn and refresh our minds all about the parts of a circle and how we might use them. So our star words today are circle, diameter, circumference, radius, and center. Hopefully some of those are ringing a bell. If they're not, that's okay. We're going to go through them all. So the perimeter of a circle, the way all around the outside, is called the circumference. That's the circumference of a circle, all the way around the outside. The middle of a circle is called the center, funnily enough. The distance from the center of the circle to the circumference, so this blue line here, or the small line, if you can't quite see the blue, is called the radius. The small line from the center to the edge, it's got to be a straight line, got to be from the center, it's called the radius. Now the distance across the whole circle passing through the center is called the diameter. Now again, it must pass through the center. You can't just do a random line somewhere. So this is the diameter, this is the radius. Hopefully by looking at these, you might notice the relationship between radius and diameter, which we'll speak about later. So circumference around the edge, center in the middle, radius from the center to the edge, diameter all the way across, passing through the center. So before we move on, you're going to do a quick identification activity on mathematics. So you just need to identify the radius, the diameter, the center. That's all you need to do. So go and log on to Mathletics and get that done. Don't panic if it asks you the same question 4 times in a row. It's just quick checking that you know exactly what those parts are called. It shouldn't take you very long at all. It took me a few minutes. So it's a quick activity and then back when we're going to do a main part of the lesson. Off you go to Mathletics now. Great, let's move on. So the relationship between the radius and the diameter that we were talking about earlier, the radius is half the diameter. Or we could say the diameter is double the radius. Whatever it is, the diameter is bigger, 2 times as big, and the radius is half as big. So if the radius of this circle was 5 centimeters, should be really quick, bit of thinking. If this is 5 centimeters, how big is this line if we said it's double? Hopefully, instantly, we're saying, yes, 10 centimeters. Perfect. You can almost see it, because if we tipped this one, I wonder if it'll let me, if we tipped this one on its side, you can see it's halfway along. So there, if this bit's 5 centimeters, this bit's 5 centimeters. So simple as that. So what I'd like you to do is, using that in your home learning books, please write down the missing measurements for each circle. So here I've given you the radius, and you need to sum the diameter. Here I've given you the diameter, you need to sum the radius. Again, giving you the radius, but this time decimalized, so be careful. And here I've given you the diameter, again decimalized, so be careful, sum the radius. So pause it, have a go at noting down the missing. Oh, I've not put a question mark there. I'm going to put a question mark there. So note down the missing measurements, please. Pause it and have a go. Good stuff. Hopefully that wasn't too challenging for you. Hopefully it was okay. If it was and you found it a bit tricky, just send me a message on Teams, ping me an email, and we can see if we can help out. So here we had radius of 6, diameter of 12, diameter of 16, radius of 8. Radius of 8.25 means diameter is double, 16.5. 16.50 would be acceptable as well. Here, diameter of 22.6, half that is 11.3. Those are your answers. So now we're going to look at some problem solving and reasoning questions, and I'm going to go through one with you. Now this question you will have a bit later because there are more parts to it, but I thought we'd go through one part of it together. So here are 2 circles. Circle A is blue. Circle B is orange. Circle A, for those of you that might struggle to see the blue, circle A is the middle circle with the line across it. Circle B is the big circle. The diameter of circle A, the blue one, the small one, is 3/4 of the diameter of circle B. So this length is 3/4 of the total length. If the diameter of circle B is 12 centimeters, what's the diameter of circle A? So the big diameter of circle B, big line across, going through the center, is 12 centimeters. I want to know the diameter of circle A. So I know the diameter of circle A is 3/4 the length. So first I need to find 1/4 of that big length. So 12 divided by 4 is 3, that gives me 1/4. I want 3/4 for the diameter of circle A, so 3 times 3 is 9, meaning the diameter here of circle A is 9 centimeters. So we're using what we know of circles, we're using what we know of mathematical fractions and things to answer these questions. So what I want you to do, in your home learning book, I've given you questions 1, 2, and 3. Question 3 has 1, 2, 3 parts. I've taken out a part because we used it. So question 1 needs you to agree and explain your reasoning. Question 2 needs you to explain why he's right or wrong. And question 3 requires you to find diameters and radiuses based on the rules we just talked about. Be careful, they change diameter and radius around. So here it says diameter, what's the radius? Diameter, 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 radius. Be careful, read each part carefully. Have a go at those in your home learning books, pause it and have a go, and then we'll go through each one's answers. All right, let's crack on with some answers. So first one, Alex says the bigger the radius of a circle, the bigger the diameter. Do we agree? So Alex is absolutely correct because the diameter is double the radius. So no matter how big the radius is, if the radius gets bigger, the diameter has to get bigger as well because it's double it. So the bigger the radius, the bigger the diameter, absolutely. Because if a radius of 5, the diameter is 10. Radius of 7, the diameter is 14. It absolutely follows. Second one, spot the mistake. Tommy has measured and labelled the diameter of a circle below. He thinks the radius of this circle will be 3.5. Is Tommy right? Now, he's absolutely, the diameter is 7, and the radius would be 3.5, but Tommy has measured the diameter inaccurately. Why? Because it does not pass through the centre of the circle. It just is a random line. Okay, so remember we said it needs to pass through the centre of the circle, so he's incorrect. The last one. So, 2 circles, A is the centre one, B is the big one. Centre one, diameter is 3/4 of the big one. So if the diameter of circle A, this one here, is 12, what's the radius? So if the diameter is 12, that's 3/4 of the big diameter. So I want to find a quarter. So I do 12 divided by the numerator. So the number of quarters I've got. So 12 divided by 3 is 4. So that means 1/4 of the diameter is 4. I then times that. Instead of by 3, which is for the small circle, I want the whole. So I'll be timesing it by 4, which would be 16. So the diameter is 16, but we were asked for the radius, so we chop it in half, and the radius would have been 8. Next one down. The diameter of circle B is 6 centimeters. So the big circle is 6 centimeters in diameter. What is the diameter of circle A? So we need to find a quarter. So we do 6 divided by 4. The 6 split into quarters divided by 4 is 1.5. We then need 3/4 of it for this diameter. So we times 1.5 by 3, so 4.5. So the diameter of A is 4.5. The last one, the diameter of circle A, the small circle, is 6 centimeters. What's the radius of circle B? We do exactly the same as we did in the top question. We divide it by the numerator, so 6 divided by 3 is 2. We times that by 4 to get 4 lots of 4, which is 1 whole. So 2 times 4 is 8. So the diameter is 8, and we wanted the radius, so we chop it in half for 4. Took me ages because I tried to do some clever maths and think of the wrong rules, but actually we just divide by that numerator. That's what tried to throw me. But well done if you got any of those. To finish the session, on Timetable Rockstars, have a bit of practice for me, and then you can finish and we'll do our last lesson tomorrow. Bye-bye.